Okay, good morning, good afternoon, good evening, whatever time you are starting your e-learning for today. I promise this one's going to be much shorter than it was on Monday or Tuesday, okay? That was a review, so I had to squeeze quite a bit into one lesson, but today is a lot shorter, okay? So we're going to learn how to solve quadratic equations by factoring. Remember that all of your assignments can be submitted even from quarter 3 and also from your e-learning. And remember that e-learning is going to be 50% of your final semester grade. Please use your Riverside email address. If you do not use your Riverside email address, then your IP will not open when you click on the link on Haiku. So make sure you are using that Riverside email so that it works. Please come and say hey during office hours from 10 a.m. to 11 a.m. If that time is too early for you, please email me and we can set up a one-on-one meeting, okay? Struggles and celebrations. So I have a struggle that turned into a celebration. Basically, one of my favorite restaurants is called Happy Dragon, and because of the times, they're closed. So I'm not really able to go in there and get my food as I would love to do. Also, the owners are pretty cool people, and I've gotten to know them over the years, and so I really miss also just being in their space. So after I complained for a while, I decided that I would go ahead and try to cook one of my favorite meals from there, which is egg rolls, fried rice, and teriyaki chicken. And if I say so myself, it was pretty good. It wasn't Happy Dragon version, but it was pretty delicious, and it gave me something to do and something else to think about besides what I was missing. But I definitely can't wait until they reopen. I'd love to hear from you, either your struggles or your celebrations, just to let me know what's up with you. Remember that it's important that you watch the entire video, especially now that I'm doing the code word of the day that you'll have to write down and type into your IP. So please watch the entire video. Make sure you're taking notes, and if you do not have a pencil or paper at this time, I need you to go ahead and grab that. Remember to redo any assignments that you're not happy with. If you feel like you want a better grade, please just resubmit the assignment. I really suggest that you come to office hours first, though, so that I can help you out. That way you can get a better grade. Okay, so make sure to email myself if you would like to get some help with that before you recomplete the assignment. All right, so I want you to pause the video right now, and I want you to get some practice with these factoring problems. They will really come in handy during our lesson today. So go ahead and pause and come back when you are done. So what we're going to do here is we're going to factor m squared plus 2m minus 24. So what we need to do is identify A, B, and C. A is 1, B is 2, and C is negative 24. So we need to find two numbers that multiply to negative 24 and add to 2. Those two values are 6 and negative 4. So we'll have m squared plus 6m minus 4m minus 24. We are going to group the first two terms and the second two terms, and we'll put that plus sign in between. So we can take out an m from the first two, and we'll have m plus 6 left. And then we can take out a negative 4 from the second two, and we'll have m plus 6 left. So we can have our two factors of m plus 6, and we'll take that away. And we'll be left with m minus 4. Okay. For the next one, we have 2m squared plus 6m minus 108. Okay. We have our GCF here, our greatest common factor, and that's going to be 2. So when we take out a 2, we'll be left with m squared plus 3m minus 54. So we need to find two numbers that multiply to negative 54 and add to 3. Those numbers are going to be 9 and negative 6. So we're going to draw a line down to the end because we're lazy mathematicians and it makes our lives easier not to have to carry that 2 along the way. So we'll have m squared plus 9m minus 6m minus 54. We'll group our first two terms and our second two terms. My negative sign didn't make it inside, so I'll make it right down there. So we'll have an m that we can take out with m plus 9 left. And then we have a negative 6 that we can take out from the last two, and we have m plus 9. So our two factors are m plus 9 and m minus 6 with our greatest common factor of 2. All right, so we're going to get started with our lesson for today. It's called Solving Quadratic Equations by Factoring. By the end of the lesson, you will be able to solve a quadratic equation by factoring. If you do not know how to factor, please stop this video and watch the factor review video from Monday and Tuesday. You must know how to factor in order to solve quadratic equations by factoring. So, in order to solve quadratic equations by factoring, we have to follow 3 steps. The first step is to write the quadratic in standard form. The second step is to factor the quadratic. And the third step is to use the zero product property to find the zeros. Okay? Let's dive deep into all 3 steps before we do them all together. So for standard form, the standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are constant values. Standard form tells us that one side of the equation must be equal to 0 before it can be solved using factoring. For instance, if we have 2x squared minus 9x plus 14 equals 0, this would be in standard form because the quadratic equation is equal to 0. However, x squared minus 5x equals negative 3 is not in standard form only because the quadratic is not equal to 0. It is equal to negative 3. In order for us to solve a quadratic, all quadratic equations must be in standard form before solving using factoring. So let's practice this. Determine whether the quadratic equations are in standard form. So we have example 1 is x squared plus 3x minus 2 equals 0 in standard form. How do we know? So the answer would be yes, and we know because the quadratic equation is equal to 0. Okay. What about 5x squared minus x equals 4? Is that in standard form, and how do we know? So the answer would be no. This is not in standard form because the quadratic is not equal to 0. It's equal to 4. Okay? Now, I want you to go ahead and pause the video while you try example 3 and 4. Example 3, is 4x squared plus 8x plus 3 equal to 0? And how do we know? The answer for this is yes. And the explanation that I want you to write, and I also want you to make sure you write the same explanation on your IP, is that the quadratic equation is equal to 0. Okay, example 4. Is x squared minus 2x equals negative 7 in standard form, and how do we know? So no, and the explanation is the quadratic is not equal to 0. It's equal to negative 7. So we agreed that 5x squared minus x equals 4, and x squared minus 2x equals negative 7 were not in standard form because the quadratic equation was not equal to 0. Therefore, we must write the quadratic equations like these in standard form before we can solve them by factoring. Okay, so if I wanted to write example 1, which is 5x squared minus x equals 4 in standard form, I need to get my 4 on the left side of the equal sign. So I need to move it over. So this is when we go back to our inverse operations. I have a positive 4. If I want to move a positive 4, I have to subtract it from both sides. Okay, so I cannot combine my negative 4 with negative x because they are not like terms. So what I do is I write 5x squared minus x minus 4. I don't combine any of them. I just end up with that trinomial on the left side. And then on the right side, I have it set equal to 0. So now it's in standard form. Okay. Example 2. Write x squared minus 2x equals 7 in standard form. So here the issue is that negative 7 needs to be moved to the left side of that equation. So back to my inverse operations, what is the inverse of a negative? It would be a positive 7. I cannot combine my 7 with 2x. So I'll have x squared minus 2x plus 7. I have that trinomial again, and that'll be equal to 0. So now it's in standard form. Okay? I want you to go ahead and pause the video and try example 3 on your own. So we would need to subtract 13 because the inverse of a positive 13 is a negative 13. And I'm going to do that on both sides. I cannot subtract 13 from 2m because they are not like terms. So I'll write them separate. And that'll be equal to 0. Okay, so now all 3 of these quadratics are in standard form because they are equal to 0. All right, so for the third step, in solving a quadratic equation by factoring, we have to use the zero product property to find the solutions to the quadratic equation. So in order to find the solutions to the quadratic equation, we must use the zero product property. The zero product property simply states that if 2 terms are multiplied to make 0, either one or both terms should be equal to 0. So for example, we have 4x equals 0. 4 is one term and x is another term. We have to decide which of those terms are equal to 0. Well, 4 is not equal to 0. 4 is equal to 4. So that means that x is what equals 0. So when we plug in that 0 for x, that's how we get 0 for the final equation. Okay, so that is a simple explanation of zero product property. Let's see how it relates to factoring. So in example 1, it says solve a plus 1 times a plus 2 equals 0. If I wanted to find the zeros of this equation here, I have to take each factor and set it equal to 0 and solve. So I'll have a plus 1 equals 0 and a plus 2 equals 0. Okay, I need to subtract 1 from both sides. And here I'll get that a equals negative 1. I'm done. That's my first solution. My second solution comes from solving this here. So I'll subtract 2 from both sides. And I'll have a is equal to negative 2. So my two solutions for example 1 are a equals -1, and a equals -2. Whenever we're solving a quadratic equation, we can either have two solutions, one solution that we're going to be looking for. And most of the examples that we do will have two solutions. Okay, on your IP, you will have a problem where it comes out to be the same number for your solution, and if ever you have the same number, it just considered one solution. Okay, go ahead and pause and try example 2 on your own. So we'd have k plus 1 equals 0 and k minus 5 equals 0. We're going to solve both of these separately to find our individual solutions. So k equals -1. We'll add 5 to both sides here, and we'll have k equals 5. Okay? All right, example 3. Solve 4k plus 5 times k plus 1 equals 0. So even though there's that 4 in front of the k, we are still going to set up two separate equations. This time we have a two-step equation, and that's okay. So we're going to subtract 5 first. We'll get 4k equals -5. And we're going to divide both sides by 4. So k in this case is -5/4. It's okay if we have fractions. And here we'll have subtract 1 from both sides. K will equal -1. So our two solutions there are -5/4 and k equals -1. Go ahead and pause and try example 4 on your own. So for some reason, my example 4 did not show up on here. So it should be 6c plus 7, I believe, or -7, I'm not sure. And then c minus 1 equals 0. Okay? So go ahead and try this example on your own now. So we'd have 6c plus 7 equals 0 and c minus 1 equals 0. We'll subtract 7 from both sides. 6c equals -7. Divide by 6. So c equals -7/6 for that one. And then this one here, we're going to add 1 to both sides. So c would equal 1. That one got a little messy, but the answer should be -7/6 and c equals 1. All right, so let's put all three steps together. So solve the quadratic equation by factoring. First step tells us to write the quadratic equation in standard form. So what we're going to do here is we are going to add 24 to both sides. Okay. So we'll get n squared minus 10n plus 24 equals 0. Okay. Now we can factor. So step 1's done. Now we can factor. So we're going to have two numbers that multiply to 24 and add to -10. So that's why I said if you do not know how to factor, then trying to solve a quadratic equation by factoring will be difficult once you get past step 1. So if you need more review on how to factor, please stop here, go back to the lesson from Monday or Tuesday, and review that, and then come back and try. So the two numbers here would be -6 and -4 are the magic numbers. So I'll have n squared plus, excuse me, not plus, n squared. Then we're going to have minus 6n minus 4n plus 24 equals 0. We're going to group the first two terms and the second two terms with that plus sign in between. We can take out an n from our first two. We'll have n minus 6 left. And we can take out a -4 from the second two. And we'll have n minus 6 left here equals 0. Okay, so our factors are going to be n minus 6 and n minus 4 equals 0. Okay, so we factored it. Now we need to use the zero product property to find the zeros. So we're going to have n minus 6 equals 0 and n minus 4 equals 0. If we add 6 to both sides, we're going to have plus 6 plus 6. So here n will equal 6. And then we're going to add 4 to both sides here. So n will equal 4. So our zeros here are n equals 6 and n equals 4. And we have found the two solutions to the quadratic, n squared minus 10n plus 24. Okay, go ahead and pause the video and try example 4. All right, I want to take us through how to solve example 4. First, we need to get it in standard form. So we're going to subtract 18 from both sides. We'll have n squared plus 3n minus 18 equals 0. Now I need to factor, so I need to find two numbers that multiply to negative 18 and add to equal 3. And that's going to be 6 and negative 3 as our magic numbers. So we'll have n squared plus 6n minus 3n minus 18. Group the first two terms and the last two terms with the plus sign in the middle. We can take out, I forgot to check off what we've done. So we wrote it in standard form and now we're factoring. So we can take out an n, we'll have n plus 6 left. Take out a negative 3 and we'll have n plus 6 left. And this is all equal to 0. Can't forget to bring that down like I just did. Our factors are going to be n plus 6 and n minus 3 is equal to 0. So we're done factoring. Now we need to do step 3, which is use the zero product property to find zeros. So we'll have n plus 6 here equals 0 and n minus 3 equals 0. So we're going to subtract 6 from both sides. So we'll get n equals negative 6. So n equals negative 6 is one solution. And then when we add 3 to both sides here, we'll get n equals 3. So our two solutions are n equals negative 6 and n equals 3. All right, another example. We have solve x squared minus 11x plus 19 equals negative 24. This looks a little different. This time we have 3 terms on the left side. But we still need to write our quadratic equation in standard form first. So when I add 24 to both sides, this time I need to combine it with its like term. So x squared and 24 aren't like terms, so I won't put it there. Negative 11x and 24 aren't like terms, so I won't add 24 there. 19 and 24 are like terms, so I will add 24 to this 19 here. Okay, so I'll have x squared plus 11x I'm sorry, let me change this problem really quick. This problem should actually have a 5, not a 24 here. So when we solve it, we're going to solve it as though that's a 5. Okay, so we're going to add 5 to both sides. So we'll have x squared minus 11x plus 24 equals 0, because these two cancel. So I need to find two numbers that multiply to 24 but add to negative 11. That's going to be negative 8 and negative 3. So x squared minus 8x minus 3x plus 24 equals 0. We'll group the first two and the last two. Take out an x from our first two terms with x minus 8 left. And then take out a negative 3 from the second two terms with an x minus 8 left. All equal to 0. Our two factors are going to be x minus 8 and x minus 3 equals 0. Okay, so we have wrote our equation in standard form because we have 0 on the right side. We factored it. Now we need to do step 3, which is use the zero product property to find the zeros. So we'll have x minus 8 equals 0 and x minus 3 equals 0. Well, when I add 8 to both sides, I'm going to get x equals 8 here for one of my solutions. And when I add 3 to both sides, I'll get x equals 3 as my other solution. So the solutions to this quadratic equation are x equals 8 and x equals 3. Go ahead and use my solution from example 1 to try example 2. Don't forget to pause while you try it. All right, let's go through example 2. First things first, we need to get our equation in standard form. So we're going to subtract 5 from both sides. We'll have n squared plus 7n plus 10 equals 0. Notice I subtracted 5 from 15 because those are like terms. I can't subtract 5 from 7n because they're not like terms, and I can't subtract 5 from n squared because those aren't like terms either. Now I need to find two numbers that multiply to 10 and add to equal 7. Those are going to be 5 and 2. So we'll have n squared plus 5n plus 2n equals 10. Oops, excuse me. Plus 10 equals 0. Not sure what I was saying there. Okay, we're going to group the first two and we're going to group the last two. We can take out an n from the first two with n plus 5 left. And we can take out a 2 from the second 2 with n plus 5 left. And that's equal to 0. So our factors are going to be n plus 5 and n plus 2, all equal to 0. Okay, so we wrote our equation in standard form. We factored the quadratic. Now let's go ahead and use the zero product property to find the zeros. So we'll have to set up two separate equations, n plus 5 equals 0 and n plus 2 equals 0. So our first solution, when we subtract 5 from both sides, we'll get n equals negative 5. And when we subtract 2 from both sides, we'll get n equals negative 2. So our solutions are n equals negative 5 and n equals negative 2. All right, so let's apply this to a real life scenario. Suppose we know that the area of a rectangle is 234 feet squared. The length of the rectangle is x plus 8 and the width is x plus 3. Can we find the dimensions of the rectangle? Perfect, so we need to solve for x. So what we need to do is follow our area equation, which is length times width equals our area. So length times width equals area. So it tells us that our length is x plus 8 and our width is x plus 3 and the total area is 234 feet. So I need to multiply x plus 8 and x plus 3. So let's do some side work over here. So x plus 8 times x plus 3. Let's do the distributive method. So we'll have x times x plus 3 plus 8 times x plus 3. So this will give us x squared plus 3x plus 8x plus 24. And we can combine these two like terms to get x squared plus 11x plus 24. Okay, so we can now write this portion over here into our problem. So x squared plus 11x plus 24 equals 234. So now we can factor. We need to find two numbers that multiply to 24 but add to equal 11. Those numbers are 8 and 3. So we'll have, it seems here that Miss Lockhart made... before I can continue, I'm sorry. If I want to solve this equation that I have by factoring, I can't solve it yet because I do not have my quadratic equal to 0. It's equal to 234. So what I need to do is I need to subtract 0 from both sides first. Excuse me, subtract negative 234 from both sides first. Okay, so I'll end up with x squared plus 11x minus 210 equals 0. Now I can factor this, okay, because my quadratic is equal to 0. So we're going to scratch what I said before about finding two numbers that multiply to 24 and add to 11, because that would have been wrong, okay? And I don't want you to make the same mistake. Now we can do that. So we need to find two numbers that multiply to negative 210 and add to equal 11. So those numbers are going to be 12 and negative 10. All right. One second. 210 divided by 10 is 21. Okay, not 12. Some dyslexia is popping in here. So this should be a 21, not 12. Backwards there. Okay. So now we're going to plug those numbers in. 21 and 10 here. So we'll have x squared plus 21x plus minus, all the mistakes here, minus 10x minus 210 equals 0. And when you factor this all out, you're going to get x plus 21, and you'll get x minus 10 equals 0. Now we need to use the zero product property to find our zeros. So we'll have x plus 21 equals 0 and x minus 10 equals 0. Well, when I solve x plus 21 equals 0 for x, I subtract 21 on both sides, and I'll get that x equals negative 21. When I solve x minus 10 equals 0 for 10, I'm going to add 10 to both sides, and I'll get x equals 10. So when they ask me to find the dimensions of the rectangle, I have to decide which x value is okay. Well, I can't have negative lengths, so x equals 21 is not a solution that works. The only solution that works is x equals 10. So let's go ahead and find the dimensions like it asks us to do. So we're basically going to plug in 10 for our side lengths. So we'll have 10 plus 8 to get our length, so our length is 18. And then to get our width, we'll plug it into x plus 3. So we'll have 10 plus 3, and that'll equal 13. So we found the dimensions by applying our rules for solving quadratic equations. All right, great job today. Please go back to my haiku page and find the link for solving quadratics by factoring IP. Please use the video, your notes, and office hours to complete this. Please email me with any questions or concerns. I really miss you all, and I hope to see you during office hours sometime this week. Have a good day.